As Ray said, I am Sarah Groff Palermo. That is a lot of names. I am also Sarah GHP. Should you look for me on the internet, you can find me at sarahgp.com. If you like what I say, my Twitter is supersgp. If you don't like what I say, that's definitely not my Twitter. So right now, I am an engineer at Kickstarter. I work on the front-end team there. But before I was an engineer, I was a designer and a data visualization engineer. So I made things like this, which is a really cool matrix all about arthritis symptoms. I made weirder visualizations too. This is a cool GIF about elephants. You can visualize how many exist and how many poachers there are. It's a very depressing but awesome GIF. I make weird data art too. This is a visualization of my library. And sort of the reason that this is relevant to what I'm talking about today is they're all really about making information available visually. And so what I'm going to talk about today is Label Goes Here, which is a talk about diagrams, which really unites all these interests. I wanted to call this talk Diagrams, Motherfuckers, because I feel like really passionate about how great they are. But it seemed to me like I was calling you guys motherfuckers, and I'm not quite that metal. So instead, we're just going to talk about Label Goes Here. And so what I'm going to cover is talk about using diagrams for communicating about programming, right? Both with other people and with our past and future selves, which is a lot like communicating with other people, but you always know who to blame when stuff goes wrong. It was past you. And so I'll talk a little bit about using it for ourselves, using it internally, externally, and then at the end, talking about going forth and diagramming yourself. And no matter what, in the end, diagrams are about relationships. So these are some of the earliest diagrams. These are Euler's logical diagrams. This is basically your and in your or visualized. This is where Venn diagrams come from. And they're all about the logical relationships between sets. Diagrams can also look like something you totally wouldn't expect. I don't know if anybody is familiar with this cartoon. It's from Lynn Clark's Redux, How to Redux. But it's actually a diagram, right? It's a diagram with characters, so you remember what's going on in it. But it's pretty much the same thing as this cool diagram of flux architecture, but more fun. So there's also, diagrams are just a really cool way to communicate. This here comes from Euclid's Elements of Geometry and illustrates one of the really good perks of using diagrams, which is that rather than having to look up the letters for the angles and see how all the geometry is related, you can just literally look and say, yes, this parallelogram and this parallelogram are the ones that we're talking about. And it makes it far more apparent. Diagrams are really cool because they tend towards a high level of abstraction, right? The forest level. And this lets us generate insights about general organization and lets us see the choices we've made in a really holistic manner that can help us, shift on a broader level and make sure that we're working up to the sort of code desires that we have, the patterns that we expect. So let's talk about documentation. Do you ever get annoyed sometimes if you're interneting around and trying to figure out how to use a library? And you want to understand the API, and all you can find is tutorials, but no conceptual description. So say there's somebody that you know who made this really cool library where you can use P5JS with hardware, and you want to use it, and you're just oh, all I can find is this stupid tutorial, which is cool. And if I wanted to blink an LED, that's really great. But what you're actually yearning for is sort of the ability to look at it like this, to say, what does it do? It lets me, use a browser and a server and a microcontroller and go back and forth. And you want it really badly. And a lot of times I have found that it's really hard to get for a lot of tools that we use. And so if you're like some of the engineering students that Richard Felder studied, he's a computational sociologist, you might be 60% of you are what? No, I love tutorials. Tutorials are great. Why are you complaining? But the other 40% are oh my God, yes, why won't somebody just show me a picture? And this distinction is actually a difference in learning style, which is to say the global and sequential difference. And it's part of 4 spectrums of learning styles, which, if you're familiar with Myers-Briggs, is kind of like Myers-Briggs for learning. One of them is actually a Myers-Briggs spectrum, the intuitive versus sensing. And so, right, visual versus verbal is obviously learners who prefer to see things versus hear them. Active and reflective is, do you want to do stuff with your hands? Do you want to think about it? But the one we're talking about right now is sequential versus global. And the sequential learner likes to learn by taking small bites of information and sort of putting them into practice, and is very comfortable working with incomplete knowledge. I am not like these people, right? And if you're a global learner, you sort of struggle to know how to file information away until you have a general understanding of the system. Or another way to put it, in words this time, is that once I understand all the parts, I understand the whole thing would be the sequential learner, versus the global learner would say, once I understand the whole thing, I see how the parts fit together. So I think we can see, right, how including diagrams by default into your documentation is sort of a kindness to this global style of learner. By giving her a general view, you make the specific points easier to relate. And they suit the visual and the intuitive learner really well too. So by just making sure you have some pictures in what you're making, you're really opening it up to a much wider group of people. So now you're like, yeah, Sarah, I love diagrams. You're super right. What does a good diagram look like? This is one of my favorite ones, and I like to choose it because it's about art and not about programming, so people don't get lost in whether they think it's the most accurate or not. And so it's about Cubism and abstract art, and it really shows how you can start to approach learning with a diagram, right? Just by looking, we can say, oh my God, Fauvism takes in all of this information and doesn't influence that many people, versus Cubism being the super opposite. Cubism only has a couple of influences, but it's got its fingers in everybody's pie, from De Stijl over to abstract expressionism. Everywhere you want to do work, Cubism is there. And you can see how if you started with this diagram and you wanted to learn a little bit more about modern art, you could do something like say, oh, what's the history of abstract art? And start all the way at the bottom and move back up. Likewise, we can see that if you wanted to dial in onto location or year, they're on the diagram and they're ready and they're there for us to sort of grasp and start working with. It's obviously a lot more easy to grasp than, say, this paragraph, even if, in the end, the paragraph might give you details unavailable in the diagram. And so this approach has been written about by Ben Schneiderman. He calls it the visual information seeking mantra. And it describes design methods for high bandwidth information processing. So basically what you're looking to do when you create a diagram is you want to give people the overview first, the option to zoom and filter, and then to get details on demand. And something that I think is very interesting about working for this approach as well is a lot of the people I know who are sort of less traditional developers who came from different places tend to be a lot more global thinkers. That a lot of sort of standard CS education right now is all about the accretionist approach. And by making sure that we're talking about things in this broader way, I think it really opens it up to people who might be logical and love systems, but maybe never woke up one day and said, yes, math is like my thing. So they're not just good, though, for documentation for your bigger projects. They're really, really useful for internal repos, too. So, and in this case, unlike external documentation where you're really trying to get people to use your work, you can be lightweight and even partial. So this is a little quick conversation that I had on GitHub with one of my coworkers about some functions I wrote about formatting credit cards, as one does. And his question was basically assuming that functions were being applied in a separate order than they were. But why would he know that? It wasn't implemented yet. They're just formatting functions. And so, right, we have this conversation, which was a nice conversation. Everyone was really happy. But it probably would have been even easier if I had included this with my code when I first put it up. And I did end up putting it in the PR eventually. Right? And so in this case, it's really clear what each function is doing and why it's doing it. You can get that big overview of what we have. You can already start poking holes in what's going on, which is also very helpful, right? Why is there not a format expiration function? And in this case, that hole is there for a reason. It's not a text input, so it doesn't need to be formatted. It's just drop-downs. But you can look at how you can start asking questions and make it really apprehensible for the people who are working with you. They know what I did. They know why I did it. They don't have to read a whole bunch of code. Sometimes it is, when you use diagrams, it is about the structure entirely. This is also a more low-key diagram I made for a project I did with the Office for Creative Research, who I did some of that data viz that I showed you before. And it was our first project using Webpack and React. And people were like, oh my gosh, this is really hard. I don't know where everything goes, really good engineers who are just like, this system seems super complicated. So, I drew a picture for how I assembled everything and put it in our repo so that when people came in and wanted to know both where to look when things went wrong, as well as sort of knowing where their files went, we had a really simple answer for that. This is another one from a friend of mine. He likes to put his diagrams right into his code. This is from an agreement system that he worked on. And basically, documents can be in a ton of different states if you have two people who need to agree on them and approve them, et cetera. And so again, rather than make things complicated or write 10 paragraphs, he makes it really clear in the code where things can possibly be going. So that's sort of diagrams with communicating for other people, which is maybe the most obvious case, communicating with other coworkers, second most obvious case. But I've actually found diagrams to be even more helpful for communicating with myself and for refactoring. So we'll talk about two parts. So sometimes it takes place before I start to code, right, which is diagrams for planning. And you can get UML-y and weird, but mine are really simple. So I have a project called Data Monster. It's a DSL that transpiles to D3.js. I'm just using it as an example. So basically, you write that much code, and you get all of this D3 out of it. And so it was one of my first bigger projects, and writing a transpiler. And I was like, OK, how does it work, right? So I'm sure you guys have all drawn stuff like this. It's like your first thing. You're like, oh my God, what am I going to do? I'm going to diagram it all and write all the questions. Then I sort of go through and consolidate it further. So now we can just see the general text processing that's going to go on. And I start working from there. I could feel my way through and elaborate on each step and sort of dive in and go piece by piece. And then finally, I get like all down in there and wrote it. And then you come back up at the top and you're like, oh my God, what did I do with my life? And this is my favorite time to use diagrams, so just to use them for refactoring. All the rest of this talk is mostly just stuff to entertain you so that I can make this pitch here. So it's really great because you get lost and you put everything together, but then when you draw the picture, you can find out what you've done and the mistakes that you've made. And so it's a little useful to know before we look at the slides that basically the way a transpiler works is like this. Users take the code that I showed you. It goes through the parser file, which creates an AST, which is an abstract syntax tree. It's basically how your compiler represents the words that you typed into it. And that AST goes through the interpreter, which creates an intermediate representation that can then be parsed by the writer to create the transpiled JS. It's useful usually to break things into these two pieces because A, if you decide that the way your parser works is stupid, you can actually still use most of your work and just change the intermediate representation. And other people can create intermediate representations if they too wanted to generate D3 for unknown reasons. So I was like, all right, I'm going to draw a diagram of this. And this is what the interpreter file looks like the first time I wrote it. This is how the functions work. This is how the data falls through. And you can start finding big mistakes right away, right? Like, what the fuck is that? Like, that's crazy. What did I do? Why did I do that? It's way more apparent when you draw the picture than it might be. Should you be scrolling through your functions? You're like, oh, yeah, everything makes tons of sense. This one calls this one calls this one. Like, no, that's clearly a bad idea. They're calling the same functions. Pipelining stuff would probably help. This was a couple years ago. I definitely write better code than that now. They also both call handle siblings and add children, which is weird because it sounds like they're parallel functions, but they're not named the same, right? Like, that's kind of a weird thing that I did. And drawing it up and seeing them right next to each other makes it really clear. There's some other fun stuff going on in this diagram. I can see that I'm calling two slightly different functions, convert to func and convert to defunc, and the latter one only once. It's probably also not a good idea, right? Like, I'm sure I wrote the function once and then I was like, oh, there's this weird case. Rather than like refactor my function to take two different arguments like a normal person, I should just write a different function. So that was clearly a bad idea. Oh, right, and there's also the utility functions here that are starting to happen. It's like, maybe there should be more utility functions. Good questions to ask. And then when I look at both the writer and the interpreter, I can see that I have two cases where I basically have giant switch statements that are looking for all the special cases so that I can do things with them, which is something you would do in a DSL, and it makes a lot of sense. But maybe it doesn't need to be in both files, right? Like, maybe the intermediate representation should have dealt with this already for us. And so basically, and I did this probably about a week after I finished the first file. And it's now been refactored to fix a lot of these problems that I don't think would have been obvious had I just been looking at my code or, even trying to test it and knock my head against the wall. And it's made it a lot clearer just by sort of drawing the picture. So, there's a lot of possibility for continuing to diagram. These are sort of like the obvious obvious communications with yourself, with other people, etc. It's also really useful at work. If you keep your diagrams up to date, you can make sure that when you're refactoring things, when you're changing things, when you're adding functionality, that you're staying true to your design pattern in a really apparent way. It's hard to hide and it's hard to argue about. And by doing the work yourself, right, not using some sort of auto generator, you're making sure all the choices you're making are conscious ones. So I hope I have now convinced you guys it's a cool thing to do and you will learn stuff and you'll probably find terrible rat's nests that you've drawn. And I hope you're really excited for it. So I have a couple cool ideas or good things to remember when you go forward, and it doesn't have to be complicated at all. I always like to remember Schneiderman's mantra: overview first, zoom and filter, then details on demand. That's even a good approach to drawing your diagram, right? Draw the big pieces and then you can fill in the little ones. It's useful to ask yourself when you start, which are the important relationships that you want to focus on, and that can help affect how you're going to draw it. Is it about hierarchy? Is it about the interactions? And you can start drawing it according to that style. You might want to ask yourself, right, this is a good design question. What are the primary questions that someone are going to have? So this is the elephant one again. But really the most important thing in this whole diagram, like helping people debug by knowing where problems might be occurring in the whole Webpack Babel stack, is useful. But what's really useful is they wanted to know where to put their files to get everything up and running. And so, making sure to highlight things, this would have been improved even just by that. You can be representational and don't worry about setting up a complex system of representation, right? I was just okay, phone to cloud, we know what files look like. These are definitely databases, right? It's really simple for people to look at it and get a good idea of what kinds of things are going on without being too crazy. You can always use labels to make it clearer. And one of my final suggestions is if you've looked at UML, the arrows go the wrong way, don't be like UML. There's actually been a bunch of different studies about this, that when people look at arrows, they expect them to go from to two, and you should do that so people will understand. Finally, but how? You guys know how to approach it? You know what to do? People have often asked me what kind of tools I recommend about diagramming. Honestly, your notebook is a really, really useful one. Taking a notebook, taking a picture, throwing it into a repo, there's no shame with that. It can be a little hard to expand if it's something that you want to use as a tool within your team. So also, Keynote and Sketch are really, really good to use. I'm at Adobe, I guess I should say, also Illustrator. Keynote, if you guys don't have drawing programs too, you probably have on your machine, is actually super helpful for drawing really fast diagrams. They might not be the most beautiful ones that are going to make people cry, but they're going to be good. If you would prefer to do it in code, there's Mermaid, which generates diagrams sort of from Markdown. I've become a huge fan of playing with it. It's really useful. They have a bunch of different representations too, so this is, I don't remember which style this is labeled. I guess it's just called the generated diagram, but there's other groupings that you can just let them know that you're looking for. So I like this. It's easy. Right now, GitHub does not have the ability to convert directly from Mermaid in Markdown. I've been wanting to mess around with getting it to do so. But until then, there's always Mermaid to PNGs, and it's nice to just draw text. So I want to leave you guys with sort of a final inspiration. A really good way to learn about how to use diagrams is by example. There's a book called Thinking Forth that was called to my attention by my friend Justin Falcone. I have to give him his shout out for that. It's about Forth, which is a stack language. It's actually the language they use to put robots on asteroids and stuff, because stack languages are very efficient, especially if you're solving a very small problem, like putting a robot on an asteroid, a trajectory essentially. But the book, Thinking Forth, actually has a lot about different software design philosophy and approach. The first two chapters are super great, even if you never want to write Forth. And they have really good diagrams explaining complex concepts. So I think this is a super good example with cartoons and more clear diagrams to get you thinking about ways to draw your code. And I said I was going to try to make this 30 minutes. I lied. It's been 20. But I hope you guys are excited and you want to draw diagrams. Thank you. Yeah, we can take questions.
Rethink or look into this deeper.
Yeah, for sure. So I think the first one is the one I showed you all, my deep shame. If you have like a rat's nest of arrows, sometimes it means you laid your diagram out weird, but usually it means that you have a bunch of functions that are sort of complected together that either should be one thing that can dispatch into smaller functions, or that you need to rethink how you're pipelining your data. Another one might be weird islands. If you have, most of your diagram flows through, and then there's some like strange universe over here where like only one thing is getting sent through. Sometimes that's useful. Sometimes it means that you've broken things up right. But if there's only one and it's really weird over there, that's also, I think, a really key diagram smell. And then just noticing, I've also found cases where like I had utility functions in two different groupings. That's sort of the piece where I was talking about the writer file and the interpreter file, and they both had very similar work that probably doesn't need to be in two files, and like one grouping could take care of both of those. Hopefully, sometimes things are just going to come out bad because we all have to make compromises, but I think those are some top smells. I haven't. It's actually sort of an ideological stance on that I think drawing your own code is important rather than having the diagram generate it for you, partly because of the decisions you're making when you draw it, right? Like, if you find a rat's nest when you grouped a bunch of functions together that you thought belonged together, sometimes that's a code smell, sometimes it's like in the process of drawing it, you realize that the implicit groupings that you have been using, and those may make sense or they may not make sense, but I think it's easier for that to come apparent when you have to lay it out versus having a tool do it. And definitely when sharing with people, it's useful because it keeps you honest. I think if you can just like hit a button and it comes out, it's too easy and you've missed the like thinking part that goes along with the drawing part. It's a good question. A lot of it is doing it, which, like a lot of art, right? Practice, practice, practice. I think also Edward Tufte's books are useful. Sometimes he's a bit of a fundamentalist about some approaches to data visualization in a broader sense, but in terms of basics and drawing, those are useful. Also, Stephen Few has a lot of good data viz books.
Thank you.
Yeah.
How long does it take you to do one of those diagrams?
How long does it take to do one of those diagrams? If it's something simple, I would say 20 minutes. The more complex ones, probably a couple hours. Definitely the data monster ones that I showed you guys, that's like a couple of hours of work. And those aren't even the first versions, right? 'Cause sometimes you start drawing it and you realize you started in a bad place on the page or something else, and you're just like, fine, I'm gonna redo this. So that adds a lot of the time.
It's fun.
No, that makes sense because it's helpful. I think what I hear too is that it can be really helpful for visualizing things that contain infinite things, right? Like databases, it's a really good example that Prezi's sort of great virtue is its ability to zoom in. So if you want people to see the top level and then be like, and now we're gonna zoom in and see it, it could be really useful, yeah, for sure. And likewise, vice versa, right? If you have somebody who wants pieces, you could like use Prezi to fill in all the pieces and then zoom back out and be like, and now that's what's inside. I write small programs. I think that's part of it, right? Even when I'm working on something big, even if it's something like the Kickstarter site, which is a really big piece, it's rare that I'm needing to visualize the whole thing. I'm usually focused on one little piece. Sometimes too, right, I won't include things in the visualization. Given the knowledge level of the people looking at it, could be taken for granted. So if I were to diagram, say, our front end, I wouldn't include the node modules repo. I wouldn't include our config files because those are sort of more fundamental and I can't change them. And they're probably not the important part that I'm trying to communicate. But yeah, I think if it were something really big, you would have to choose the level of granularity that matched it, or make a really big diagram and just go like sheet after sheet, take people to like your conference room and be like, which would be a really useful communication, right? Like if what you're trying to communicate is that your work is super complex, being like, here's 10 poster sheets that explain how this all works tells a really important story even before people start looking deep inside. I have mostly just updated it myself for smaller pieces. I think that's a case where something like Mermaid would be really helpful, because then you can keep it in the repo and even have it so that to check in new code, you need to update the repo diagram and set that as a requirement. I think that's a case where I'm like working on trying to get the Mermaid interpretation files into GitHub's Markdown, because once that language is added, then I think there's a lot more possibilities. So that's like on my list of sort of Quixotic quests for the year. Awesome. Well, I'll be at the bar, so if you want to get drunk and talk about diagrams later, we can totally do that too. Thank you guys so much.